Hello, Accelerated Chemistry students. This is Mr. Spurk, and this is your Chapter 15, Section 2 notes on homogeneous aqueous systems. So first we're going to talk about solutions. An aqueous solution is water that contains dissolved substances. Now we briefly talked about solutions whenever we talked about states of matter. In a solution, the dissolving medium is the solvent, so in this case it would be the water. The dissolved particles in a solution are the solute. Solvents and solutes may be gases, liquids, or solids. Solutions are homogeneous mixtures. If you filter a solution through filter paper, both the solute and the solvent pass through the filter paper. Substances that dissolve most readily in water include ionic compounds and polar covalent compounds. Nonpolar covalent compounds such as methane and compounds found in oil, grease, and gasoline do not dissolve in water. However, oil and grease will dissolve in gasoline because they, like gasoline, are nonpolar. The solution process. So a water molecule is polar because the partial negative oxygen and the partial positive hydrogen. As an individual solute breaks ion as individual solute ions break away from the crystal, the negatively and positively charged ions become surrounded by solvent molecules and the ionic crystal dissolves, like you can see over here on the right. Those water molecules are surrounding the negatively charged green and the positively charged purple atoms or the ions, and they are dissolving them. They are completely surrounded. The process in which the positive and negative ions of an ionic solid become surrounded by a solvent molecule is called solvation. The solution process. Polar solvents such as water dissolve ionic compounds and polar compounds. Nonpolar solvents such as gasoline dissolve nonpolar compounds. This relationship can be summed up by the simple expression like dissolves like. Electrolytes and non-electrolytes. An electrolyte is a compound that conducts an electric current when it is in an aqueous solution or in the molten state. All ionic compounds are electrolytes because they dissociate into ions. A non-electrolyte is a compound that does not conduct an electric current in either an aqueous solution or the molten state. Some polar molecular compounds are non-electrolytes in the pure state, but become electrolytes when they dissolve in water. This change occurs because such compounds ionize in solution. Not all electrolytes conduct electric current to the same degree, however. In a solution that contains a strong electrolyte, all or nearly all of the solute exists as ions. A weak electrolyte conducts an electric current poorly because only a fraction of the solute in the solution exists as ions. Your cells use electrolytes, such as sodium and potassium ions, to carry electrical impulses across themselves and to other cells. An electrolyte imbalance can occur if you become dehydrated. When you exercise, you can lose water and electrolytes from your body through perspiration. That's why we drink a lot of sports drinks, and they're very popular nowadays. They say replenishing your electrolytes, things of that nature. That is for your cell and your body recovery. So hydrates. The water contained in a crystal is called the water of hydration or water of crystallization. A compound that contains water of hydration is called a hydrate. The forces holding the water molecules in hydrates are not very strong, so the water is easily lost or regained. A substance that is anhydrous does not contain water. Over here I have two pictures of the lab that we did. If you remember, we had copper sulfate pentahydrate, and when we heated it, it looked like the right-hand side because now it was anhydrous. And then we would add water back to it, and it converted back to looking like the left picture. To determine what percent by mass of a hydrate is water, we first determine the mass of water in 1 mole of the hydrate. Then we determine the molar mass of the whole hydrate. The percent by mass of water can be calculated using the following equation. The percent by mass of H2O equals the mass of water divided by the mass of the hydrate times 100%. So efflorescent hydrates. The water molecules in hydrates are held there by weak forces, so hydrates typically have a high vapor pressure, meaning that the water molecules will leave easily. If a hydrate has a vapor pressure higher than the pressure of water vapor in the air, the hydrate will lose its water of hydration, or it will effloresce. Hygroscopic hydrates. Hydrated ionic compounds that have lower vapor pressure actually remove water from moist air to form higher hydrates. These hydrates and other compounds that remove moisture from air are called hygroscopic. A desiccant is a substance used to absorb moisture from the air and create a drier atmosphere. So a desiccant is hygroscopic. Finding the percent mass by mass of water in a hydrate. Calculate the percent by mass of water in washing soda or sodium bicarbonate decahydrate. Alright, so the first thing that we need to do is figure out the mass of this whole hydrate. So if we add up these masses, the mass of Na2CO3, just that portion, is 105.99. And we're going to add that to 10 waters, so 10 times 18.016. And we are going to get 286.17 grams per mole. And so that is the mass of sodium bicarbonate decahydrate. So to figure out the percent by mass of water, we take the mass of 10 waters, which is 10 times 18.016, or 180.16 grams per mole, divided by the molar mass of the whole compound, 286.17 grams per mole, times 100%, and that gives us 62.96%. So what that means is that the hydrate, or the 10 waters, take up 62.96% of the mass. So now we're going to talk about deliquescent compounds. Some compounds are so hygroscopic that they become wet when exposed to normally moist air. These compounds are deliquescent, which means that they remove sufficient water from the air to dissolve completely and form solutions. If you look at the little photo below, that is pellets of sodium hydroxide, and sodium hydroxide is the deliquescent. When it sits out, it pulls the moisture out of the air and actually becomes a solution of sodium hydroxide. In review, substances that dissolve most readily in water include ionic compounds and polar covalent compounds. All ionic compounds are electrolytes because they dissociate into ions, and the forces holding the water molecules in hydrates are not very strong, so the water is easily lost and regained. As always, all the information on these slides has been acquired and adapted from Pearson Chemistry 2012 edition of the textbook, the resources CD, and pearsonchem.com. Have a good day, everybody.